Everyone, I am Dr. V.S. Nishak from his department SNS College of Technology. Here we are going to discuss the topic three-phase induction motor from the subject fundamentals of electrical and electronics engineering. So this is the outline of this video, which starts with need of induction motor, construction, working principle and real world applications. So why we need these induction motors? Because of its low production cost and less maintenance and its rugged usage, these sort of induction motors are reliable and less maintenance. So that is the main purpose why we are going for this induction motors. So these induction motors are classified based on the winding. So that is, if it is a one set of primary and secondary winding, it is a single phase induction motor, and if it is three sets of primary and secondary winding, it is called as a three-phase induction motors, so which are very efficient in the applications like pumps, fans, conveyors, compressors, etc. So coming to the construction part, it is further classified into stator and rotor. So stator represents the not moving parts, rotor represents the rotating parts of this induction motor. So here the stator starts with initial AC input. So when the three-phase input is given through the stator part, so it is the mainly provides the magnetic field, rotating magnetic field around this stator part, which is further useful for the inducing the EMF in the rotor part. So and the air gap between this stator and rotor represents the magnetic coupling. And then finally, for mechanical support, we will be using these frames and bearings. So coming to the working principle, it's mentioned by the Faraday's law. So Faraday's law represents when there is any magnetic field, so if we are keeping any conductor near to the magnetic field, it induces the EMF, that is called as a electromotive force. So based on this principle, it provides the electrical energy. So when a three-phase AC supply is given to the circuit, it provides the rotating magnetic field. So when the conductor is kept near this rotating magnetic field, it provides the current based on this Faraday's law. So and the point to discuss here is rotor speed is slightly less than the synchronized speed, that is further called as a slip. So here is the outline or diagram of this working principle, and this is the time for activity. And coming to the real world applications, so this either single phase or three phase induction motors are widely used in different applications like industrial application, domestic application and transport applications. So if you are going for the industrial applications, like wherever we are using pumps, compressors, conveyors, blowers, etc., we can utilize this sort of induction motors. And coming to the domestic or commercial application, in the washing machines, in ceiling fans and all, we are using this single phase induction motors. And coming to the transport application, we can utilize it in electric vehicles, metro drives, etc. So that is based on the variable field drives. And in the summary part, we can conclude by summarizing the topics. What is the need of the induction motor? Because of its less maintenance and because of its less cost, we are preferring this sort of induction motors. And coming to the construction, we have seen about the stator and rotor parts. And coming to the working principle, we can see the Faraday's law. Based on the Faraday's law, how this induction motor provides the electromotive force. So and finally, we have seen based on the different applications like industrial, domestic and transport applications where it is used in real world. So that and all we have seen in this video. And coming to the assessment part. So here in the assessment part, we are having the questions like induction motors are commonly used in pumps, conveyors and fans, and the rotor current in an induction motor is induced by electromotive. So this is induced by electromagnetic induction from rotating field. So here in this induction motor, we are seeing the new term rotating magnetic field. So, and this is the reference books and reference sites for this video. Thank you all for joining this video.